Field of diamonds in the sky, worlds a whirling right on by. Are you wondering who am I? Field of diamonds in the sky.
Welcome to all our viewers at Slooh.com, those watching on social media, and especially to all those watching on NASA TV. Today is the culmination of Spooky Week as we discuss potentially hazardous asteroid 2015 TB145, or Spooky, as it makes its closest approach to Earth in just 30 minutes time. Now, since Earth formed some 4.5 billion years ago, it suffered countless impacts by asteroids and comets. And depending on their size, they could cause massive damage either locally or global scales. But just ask the dinosaurs about that one. Now, it's why asteroids really like Spooky, the Halloween asteroid, continue to make international headlines. But what are the risks that these things really pose? And what are we doing to mitigate that risk? Now, these are the questions that we're going to be posing to an incredible lineup of experts today. We've got Slooh astronomer Bob Berman, we've got Dr. Mark Boslow, Keith Cowing of NASAWatch.com, and NASA's very own Lindy Johnson. Now, if you'd like to ask any of our guests a question, you can do that on Twitter by using the hashtag SloohSpooky. Now, this story all started when this potentially hazardous asteroid was discovered just 21 days ago. From observations yesterday, we know that it's 600 meters wide. That's nearly 2,000 feet across, and it's moving at an incredibly fast rate. Now, we need to understand a little bit more about this strange skull-like object. You're going to see this in a minute, and why scientists are so excited about it. So what is it, first of all? Look at this fantastic image coming in. This was yesterday, the radar images. Now, I hope you enjoy what we've put on for you here. We've organized not only a large asteroid or comet making its closest approach to Earth on Halloween, but we even arranged for it to look suspiciously like a skull. So what is it? What is a potentially hazardous asteroid? Well, what we think um, is that it's the heart, the core of a dead comet. Now, we need to be very clear from the outset that this asteroid or dead comet is not going to impact Earth anytime in the near future. But that's not the real story here. The real story is that an asteroid this size was only discovered 21 days before making its closest approach to Earth. So, what makes Spooky unique? Well, there are suggestions, as I say, that this is the core of a dead comet rather than an asteroid. And what leads us to that suspicion is that it had a very strange orbit, and it actually points to why this wasn't discovered as quickly as maybe we would have hoped. And its highly inclined orbit really put it outside of the main zone, as we'll hear later, where most of the searches for these near-Earth asteroids and comets actually occurs. And the other thing that makes us suspicious that it is a comet is that incredibly high velocity that we see as it whizzes by. We've got some live images coming up later that you're going to really enjoy. You'll see just how fast this thing is moving across the sky. So what do we do in order to discover and track these asteroids and comets? Well, Slooh members have been tracking asteroids for a long, long time now. We've got a great track record in monitoring asteroids. And it was back in 2008 with asteroid 2008 TC3. And that was the first asteroid to be discovered before impacting Earth. And Slooh members took this very image. There were a handful of only a few people around the planet who managed to image it only hours before it impacted the skies over the Nubian desert in Sudan. Uh, so that one kind of took us all a bit by surprise, and it is what alerted a lot of us at Slooh to get involved with this and maybe try and raise the profile of this. So we were hoping to have Bob Berman join us, but we are going to invite Dr. Mark Boslow, long-time friend of Slooh and expert in impact studies. Dr. Boslow, thank you very much for joining us. It's always a pleasure to see you here at Slooh.
Sure, happy to be here.
So, when was the last time an asteroid the size of Spooky? When was the last impact to Earth of an object of this size?
Oh boy, I guess I don't know the answer to that question. There is a database on the web in which you can look up various craters in crater sizes, and it has a list of their ages. This would generate a 6-mile wide crater if it were to hit the Earth, something of this size and speed.
Wow, I mean, look at this image that came in yesterday from the radar images. I mean, what do you think of this? What do you make of that?
Oh, this is beautiful. I mean, it's such a high resolution, nice image. You can see it rotating. You can see features on the surface. This is great science.
It is, and we're going to be getting even higher resolution images, radar images of Spooky over the coming days as well. Now, according to data from, I think it was 2010, 95% of Earth's population lives in just kind of 10% of the land. 47% I think, of continental US is unpopulated. So given those kind of numbers, what's the likelihood of an asteroid like this striking a population center?
Well, the probability of something like this hitting the Earth in the next year is about 1 in a million. And so, given that only about half the Earth, or half the landmass, which is only a third of the Earth, is populated, the probability of hitting the Earth, hitting a population place where people live is about 1 in 10 million in the next year. So it's extremely unlikely.
Extremely unlikely, but I don't know the actual figures, but it's probably more likely than me winning the lottery.
Yeah, something like that.
Kind of puts it in some odd context there, but anyway. So
Yeah.
if an object this size, and what we were able to get, the size range of Spooky was originally put just through the optical observations that Slooh members and other people were making of it. We could only estimate its size by its apparent brightness, and the estimate was 290 to 650 meters. That's about 1,000 to 2,000 feet, somewhere in that range. But it was those radar images yesterday that enabled us to pin this one down. And I believe we've got a fairly good measurement of 600 meters across, don't we?
I think we do. And the reason that the size estimates from optical astronomy are so uncertain is, like you say, we don't know how bright it is. We don't know the albedo. We don't know how much light it reflects until it gets close enough to resolve. And in this case, it did. And in fact, with the radar astronomy, the size could be determined very accurately. And it was at the high end of the estimate because it turns out to be very dark. It's not a good reflecting surface.
So, I mean, this just it really illustrates just how very little we normally know about these objects when we can only see them through optical telescopes. And this is one reason actually why this particular close pass and all of these close passes are so valuable to scientists when they come within the range of the radar, the radar telescopes, the radio telescopes, and going back to this image, I mean, we saw this yesterday, and it was just remarkable to see, and how cool to have that. I mean, human beings are good at looking for patterns, but how cool to have this kind of skull looking back at us on Halloween. So we know this is about 600 meters in diameter, which is nearly 2,000 feet. What kind of damage would an object like that? And we have to stress, this is not going to impact Earth today. It's whizzing by, it's a stone's throw in cosmic terms, but it's not going to impact Earth. If an object, though, Mark, of this size were to impact Earth, what would it do?
Well, it would create a crater. It would come screaming through the atmosphere. It would hit the surface. It would lose some energy to the atmosphere as it comes in and create a giant fireball. When it hit the surface, it would explode. It would explode with an energy of about 30,000 megatons, a megaton being the size of a large nuclear explosion. And it would create a crater about 6 miles in diameter. It would shake the ground. It would generate an earthquake of a magnitude of about 7.6, and it would blow trees down and destroy buildings over a radius of about 100 miles. So it would create a lot of havoc. It would be a much greater disaster than, for example, a large hurricane or tropical cyclone or most earthquakes.
So we're here in Connecticut. Slooh Studios are in Connecticut. We're 90 miles away from New York, 60 miles away from Hartford. If we were unlucky enough to be directly underneath one of these things, what kind of implications would there be on a city like New York, which is 90 miles away, for example?
Well, if it scored a direct hit on New York, it would completely destroy the city. Of course, now we're talking about something that's even more unlikely. The surface area of New York City is something like 1/1,000,000th the surface area of the Earth. And if there's a 1 in a million chance something like this is going to hit the Earth, then it's a 1 in a trillion chance that it's going to hit New York. So we're talking about beyond the probability of winning the lottery here. But it would completely wipe out the city, and 90 miles away, you'd have some serious damage there too. I think you could survive it 90 miles away by, sheltering in place and doing the same kind of thing that you would do if a large hurricane were coming, boarding up windows, taking shelter in basements and so forth to avoid the blast and the shower of glass from when windows blow out.
So this takes us back to what we certainly believe at Slooh is the main story here. We've never been suggesting that Spooky, the asteroid, is going to impact Earth, but the real story is that a rock this size, large enough to actually make it through the atmosphere and impact the surface of the Earth, was only discovered 3 weeks before making its closest approach to Earth. Now, should we be treating asteroids in the same way that we treat natural disasters like hurricanes or earthquakes? In other words, we know that there's nothing that we can do about them, but if we know that they're going to happen early enough, we can mitigate the impact. Excuse that term. If one of these beasts does come our way.
Well, I think the difference between asteroids and other natural disasters is we can do something about them if we have enough warning. Now, 3 weeks warning isn't enough to deflect an asteroid or keep it from impacting, but it's certainly enough warning to evacuate people and get them out of harm's way. Now, this would be an enormous evacuation to get people out of the large area that would be destroyed by something of this size, but not unprecedented. I mean, we evacuate people from the paths of tropical cyclones all the time. Earthquakes you can't do anything about. Earthquakes you fundamentally cannot predict, and so the death toll from earthquakes tends to be very high when they're in places where people are concentrated. But even 3 weeks warning for an asteroid this size, you could save a lot of people by evacuation.
Yeah. Exactly. So, it begs another question, but I just want to draw your attention to this fabulous image that we've got. This was taken with the Slooh telescopes in the Canary Islands by Slooh members, and the flare off to the top left-hand side, that's the moon, because the moon's very close at the moment. And here we see the asteroid 2015 TB145 spooky whizzing across the screen. What do you make of this?
That's beautiful. That's great.
And this illustrates very clearly that through any optical telescope, so a telescope that people would recognize with glass on the front and a camera on the back, we only ever see these objects as a small white dot. But it was when it came within range of those radio telescopes, Arecibo and Goldstone, that we start seeing the shape and the size.
And to get that shape and size information, that helps us determine the density. That tells us a lot about the composition. And now that we know the size and the magnitude, we can estimate the albedo. And people are suggesting that it's an extinct comet because it's so dark. Comets are very dark, have very dark centers.
We've got a question here using Slooh Spooky, the hashtag Slooh Spooky. Will we be able to see the dead comet as it passes Earth? Well, only through telescopes, Mark. This is not going to be bright enough for people to see with their naked eye, is it?
Oh, no. This requires a telescope. I understand at least a 6 or an 8-inch telescope to be able to see. And really, because of the time of day that it's visible, it can be seen by amateurs, but by experienced amateurs.
Yeah. And this, because it's so close, actually, its apparent speed across the sky changes quite rapidly. So it's quite difficult to track. But here we've got live images of Spooky. This is coming in from one of the observatories in China. And you can just see the fixed white points in this image are the stars in the background, and the short white line, that's the asteroid crossing the frame. And it really is. This is a very difficult one to track. So we thank our partners for all of their efforts in doing this. So back to the potential impact of an object of this size. As we say, in the 600-meter, nearly 2,000 feet class, we know that an object of this size is large enough to actually get through Earth's atmosphere and to reach the surface. What would be the impact of an object of this size hitting the ocean, Mark?
Well, that's something that we really don't know. We don't have our science complete on understanding how the energy from an asteroid would couple to a tsunami and create a tsunami. Several of us are working very hard on that problem right now, trying to understand the mechanism for the transfer of energy from a large asteroid impact to a giant ocean wave. But that's highly uncertain.
But once again, if we had sufficient warning of one of these objects on a collision course to Earth, we could start moving populations. How easy is it to determine the exact location that an object like this would actually impact Earth? I mean, can we narrow that down to a fairly small region?
Absolutely. I'm very impressed by the folks at JPL and elsewhere,
Yeah.
NASA's Jet Propulsion Laboratory, that do these orbital calculations. With the excellent astronomical observations and astrometrics, the determination of position against the field of stars, the orbit can be determined very precisely. And in fact, impacts have been predicted. There was an event in 2008, the object called 2008 TC3 that was discovered less than 24 hours before impact. And the point of impact and time of impact was calculated to the nearest kilometer and the nearest second. So there's no doubt that can be done very precisely.
And Slooh members can prove that particular example because they were one of the few people who managed to capture images of that asteroid. And I think the image was something like 4 hours before it actually entered the skies over the Nubian desert. So, and there it is. There is that very image. It's the colored line you see there, the red, green, and blue line, as we see these images of Spooky whizzing across the night sky from Slooh's Canary Islands Observatory. Dr. Boslow, it is always a pleasure to have you on our shows at Slooh. Thank you very much for giving us some context and a little bit more understanding of, how risky these are. So please, we hope to see you again soon, but hopefully not too soon, maybe.
Okay, well, chances are we'll be getting more flybys, more radar astronomy opportunities, and we really like building up this catalog of shapes and sizes of various asteroids that are passing close to the Earth. So this is a real good scientific opportunity.
Absolutely, and presumably that helps you a great deal when you're modeling your impact studies. So
it does.
Okay, well, we'll see you again soon, I hope, Mark. Goodbye.
Okay, thank you.
Now, thank you. Now, Slooh has been talking about this story for years, not just Spooky, but a whole number of large asteroids that have been discovered very, very close to their closest approach to Earth. We've been trying to raise the profile of the issue so that I don't know, to try and encourage governments and organizations to really take it a little bit more seriously. And we've always tried not to take on a tabloid approach to this. We're not into scaring people, but there is this very, very real story here that a large object like this, we've just heard from Dr. Mark Boslow there, is large enough to make it through Earth's atmosphere without burning up, to actually impact the surface. And it will have some pretty devastating local results. So Spooky is really just in the long line of last minute discoveries that we've been covering. Now, if you'd like to support us in our work to protect the planet and have some great fun along the way, then come and support us at Slooh. You can join our team maybe of members who track near-Earth asteroids and comets every single night, or maybe you just want to watch amazing live views of stunning celestial objects every night. Whatever you're into, there's space for everybody here at Slooh. We're going to take a quick commercial break now. But when we return, we're going to be switching gears from maybe the science of asteroids to what's currently being done to protect the planet. We'll have Keith Cowing of NASAWatch.com, and he's going to be helping us understand the complicated relationship between NASA and some of the private companies who are working with these asteroids and comets. We'll be right back. And welcome back. Our next guest has been following NASA's Near-Earth Object Program since its formation. And on Wednesday, he joined us to discuss that program and those of the most well-known and some say notorious private planetary defense organizations, the B612 Foundation. Keith Cowing is the editor of NASAWatch.com, and we brought him back for an encore to help us break down that story of near-Earth object tracking and planetary defense and the massive changes that have occurred over the last few years. Welcome back, Keith.
Good to be here.
Now, first off, what do you think of the amazing images that we've been seeing of Spooky already? Who'd have thought that when we launched the story on the 20th of October, that 11 days later we'd be seeing such an appropriately Halloween-shaped object? What do you make of those radar images?
I'm wondering if you actually saw it sooner. I mean, that was pretty amazing that you got a skull rotating in space.
Pretty cool. The lengths we go to organize a good Halloween celebration, here at Slooh is amazing.
It actually looks like a Homo erectus skull if you want to be accurate, but
It does actually, yeah. I thought exactly the same, and I haven't seen any composite images, but maybe we'll get those up on our social
Okay, I'll
channels a
do
little
one.
bit
Yeah.
later. Now, Keith, let's start by comparing these two programs. What does NASA currently have, both operational and planned for the future, and how did that compare to B612's plan for its Sentinel Space Telescope?
Well, NASA's been pinged on by Congress for several decades now to look for potentially hazardous asteroids. And, they gave NASA a goal and they've changed it a couple of times, but NASA really didn't take it all that seriously. They only spent $4 million on it and they never met their goals. And then they increased the budget to 40 million a year. And now NASA's saying they still can't, reach the goal of the asteroids 1 kilometer in size or greater by 2020. So, you got to ask yourself, how hard is it? I mean, you guys have just demonstrated today. You aim a telescope and you look and you see things. So that doesn't mean NASA's not doing things. And if the folks at JPL are just wizards when it comes to finding out where these things are. That said, there's a lot of rhetoric that goes with this and not as much accomplishment. Now, one group, B612, headed by Ed Lu and Rusty Schweiker, decided just to go off and do this because they could. And they got a space act agreement with NASA, and there were some things in there that they were going to do. And then, curiously, this year, around the 30th of September, NASA summarily canceled its space act agreement. It wouldn't cost them anything. It wouldn't cost NASA anything. It was all the work was being done by B612. And then the next day, they announced that one of the Discovery class mission candidates is NeoCam, which, if you show the pictures side by side, they look like they're brothers. So,
Indeed.
at a minimum, you got to wonder why that happened. And I know that there was some, because for years NASA would respond to the scientific community when they would say, "Hey, we need to be looking." They say, "No, no, no. B612 is going to do that." Well, it didn't, and they yielded to pressure from JPL and other places, and they went and pulled that agreement. So at least the B612 guys can really just be proud of the fact that they pushed the conversation
Yeah.
beyond just the "gee, wouldn't it be nice if" to
Yeah.
actual interest from NASA. But I don't think you've heard the last from B612 at all.
No, I don't either. And we've spoken to Ed Lu several times. And as you say, he said that NASA wasn't doing enough, which is why they founded B612 to start off with. And we've got a couple of sound bites actually from the last time that we spoke to Ed Lu about this.
Here's the crazy part. We're not actually looking effectively for them. We're only finding perhaps 1,000 asteroids per year. The problem is, there's about 1 million of them, at least 1 million of them that are large enough to destroy a city that are out there, and therefore, we're not going to get there at our current rate. It's crazy. So the next large asteroid to hit us is likely going to hit us without warning, and it isn't because we don't know how to deflect the thing. It's because we're not looking for them.
So some pretty scathing attack really there from Ed Lu. Now, we were hoping to get Ed on the show today to give his perspective on the issue, but since he was unable to join us, I'll ask you instead, Keith. Did NASA simply give up on B612 raising the necessary funds to build Sentinel?
Yes, they did. Yes, they did, because they had made significant progress, and they're doing a lot of things. And having done one of these things myself, the IC3 reboot project last year, we raised the money, and NASA stuck with us. So I do know that it was internal politics that pushed this issue, and it's back to the standard way of doing things, like only big NASA centers can do these missions. Well, that's not true. That's not true anymore. And by virtue of what you guys again did today, I mean, you just got people who don't have full-time jobs doing this out there seeing this stuff and sometimes beating the pros at it.
Yeah. Keith, we're going to have to tie this up because we don't want to miss actual closest approach. But could you tell me very briefly, who is it that decides on shifting expenditure from searching for these things to a redirect mission to try and nudge one of these things out of position?
Unfortunately, White House politics and OMB are in on this. So even if Charlie Bolden wanted to change things, he couldn't. And even if the scientific community, which has expressed their concern about this, wants to, they don't have the impact. It ends up, unfortunately, being White House and then a few congressional staffers who either do or don't want something to happen. So it's very messy, and it doesn't move very fast.
Okay, well, hopefully we'll be asking Lindley Johnson of NASA later on that. Keith, thank you so much for joining us again. We enjoyed the show that you came on Wednesday night. Hopefully we'll see you again. And in the meantime, I do suggest anybody who hasn't had a read of Keith's editorial on NASAWatch.com, hop over there after the show and take a read. It's quite interesting. So thank you very much for joining us, Keith.
My pleasure.
Now, if you are just joining us, look at this live image coming in from China of asteroid 2015 TB145. We named it Spooky because that's a little easier to say. Now, I'm delighted to welcome to the show Slooh astronomer Bob Berman. Hello, Bob. Welcome. What do you think of these images?
Hi, Paul. Well, it's very exciting. The whole thing, the fact that we have an object almost half a mile across, and the fact that in a minute or something like that, in the next couple of minutes here, it's going to be whizzing by at its closest approach. What a great job you're doing, Paul.
Well, what are we actually seeing in this image, Bob? Can you just explain this for anybody who's coming in late?
Yes, because this is moving so darn fast. Even if it was a slow-moving asteroid, when you're only as close to us as the moon, you're going to be moving fast. The moon moves half a degree an hour, meaning a moon width an hour. But this is not just moon speed. This is moving as fast as any object that we've ever seen, almost 40 times faster than a high-velocity rifle bullet. So, if you're taking exposure to capture the stars, which this is doing, you're not going to capture the asteroid looking like a little dot. It's almost round, but it's not going to look round because it's streaking. Just as if you take an exposure with your camera and the object's moving quickly, you're going to see it blurring or moving, and that's what we're seeing.
And we are literally, I think, less than 20 seconds away from it making its closest approach. And we've been very clear on this, Bob. This is not a threat to Earth either today or in the future, this particular asteroid. We've been saying the real story here is that an object of this size was discovered only 21 days before making its closest approach right at this very moment. At this second, this asteroid is the closest to Earth than it's ever going to be. I mean, what do you make of all of this, Bob? The real story behind this?
Well, a couple of them you've already mentioned. That how does this not get seen? An object this large, half a mile is large. This is so much bigger than the one that injured 1,000 people back on February 15th of 2013, and passing as close as the moon. That's close. You know, we do these shows, and if an asteroid is 1,000,000 miles away, that's close. This is really close. I think another story is how come it won't be a future hazard? Because usually if you're going to pass this quickly, this close to us, this kind of speed and this kind of proximity, it means that on some future orbit, it may get perturbed a little bit, and it could be a hazard to us. So the calculations show that as far as we can see, it will not hit us. So that's reassuring, and also makes it a little odd, frankly.
It does. Just a reminder for anybody who wants to ask any of our guests questions today, you can use the Twitter hashtag #SloohSpooky. Now, Bob, these are the remarkable images. As we've seen when we look through a normal telescope, we only see these asteroids, however big the telescopes are, as a small white dot. But these are the radar images that came in from the Arecibo Radio Telescope yesterday. And what we're saying here, should we rename this to Mr. Skull or something? What is it that we're seeing here in these radar images, and how come a radio telescope can image an object like this, whereas in an optical telescope we only see it as a small white dot?
Yes, well, that always is a function of how large the telescope is, or whether you have several of them side by side, so that you can get the larger the telescope, the greater the resolution. The fact that this is a series of images showing the rotation, and the people who are saying it looks like a skull rotating, you can see indentations. It looks like a bare white head to the skull. It looks like it's missing the bottom part, the jaw or the teeth.
Jaw,
The
yeah.
fact that Yes, and the jawbone. This is Halloween. At least we can breathe a sigh of relief because it just passed at its closest approach. So now, as we speak, even though it's going 78,293 miles an hour, whoa, a lot faster. Even Earth in its orbit around the sun only goes 66,600 miles an hour. So this is some 15% even faster than Earth's orbital speed. So but it's past. The danger, which actually was never there, except in the public mind, is past because now it's moving away at that fast speed. But yeah, with a little imagination, it doesn't take much. It looks like a rotating skull passing so close on Halloween. We didn't see this coming until recently. I mean, wow. We're not into hysterics or feeding media fires of the end of the world or that kind of thing. We're not. We're into science here. But still, come on, it's Halloween. We can relax a little bit and say,
Absolutely.
universe, this was a good one. You played a good one on
They
us
did a
this
good
time.
job. Yeah, they did a good one. And lining that up, I mean, absolutely fantastic. We couldn't believe it when we saw these images coming in live yesterday. And of course, we've got more higher resolution images coming in as well. Now, Bob, you mentioned it's incredibly high velocity there. That together with this very unusual orbit that this object seems to have, is this what's leading astronomers to believe that this is the dead core of a comet rather than an asteroid? And what's the difference?
That makes sense, the idea of a dead core. The difference is that comets are mostly ice balls, although they contain some solid material. We're learning more and more about them by the day, thanks to missions like the Rosetta that we just recently had. And comets come in from any direction. They don't have orbits that orbit the flat pancake-like plane of the solar system. They'll come in from high above or below or from any angle. Look at Comet Halley that comes in at a high inclination every 76 years, and all of them do. But asteroids, these are rocky bodies, mostly small, metal, rock, stones, little or no ices in them. And they orbit the sun on the same flat plane that the Earth goes around the sun. So when we're looking for asteroids, we look essentially along the zodiac or very close to the zodiac, that same pancake or CD or vinyl record, if you remember those, plane of the solar system. Not this one. This one came in from high above. It's one of the reasons we didn't see it coming, because when comets, which do often come in from high above or way below, they're much brighter. They release their water sublimates and turns into essentially steam, and this produces long tails, sometimes millions of miles long. And boy, you see them coming months or years ahead of time. So if this had been a comet with the same size core, half a mile across, we would have discovered it months or maybe even years ago. So that's what took us by surprise. You're not looking for an asteroid coming in from that angle, and it's an asteroid alone that's not going to have a coma, gases, a tail, and the glow. And plus, comets even fluoresce on their own. They're not just shining by sunlight; they're giving off fluorescence. And a tail 1,000,000 miles long, that's going to be quite bright. This thing's only half a mile long, and it's dark. So no wonder.
So Bob, just to wind up this segment of the show, we've got NASA's Lindley Johnson coming on a little bit later. But why do you think asteroids and comets capture the public's imagination and consciousness in the way that they do? Is it the risk? Is it the beauty? Is it maybe the fact that these things have delivered life to Earth? What is it that captures the public?
Well, sure. You're mentioning a lot of good things there. Comets, particularly with their water, there's an ongoing theory that our oceans, all of the water on Earth, came from the impacts of innumerable comets, which we did get hit with during the first few 100 million years of our existence. So it could have. Plus, comets have amino acids, the building blocks of life. All of the amino acids have been found, not just the simple ones like glycine. So yeah, they're intriguing. Plus, they're gorgeous. They're spooky. They're eerie. We all remember Hale Bopp, and some of them are quite famous. Asteroids, it's a different reason. There, we get close encounters from time to time. Plus, every single one, with about 100 exceptions, of the 50,000 meteorites that you'll find in museums or in people's personal collections, all of them are asteroids. There's a few samples from the moon, a few pieces of Mars that came in, but essentially, if you can hold it in your hand, here on Earth, it's an asteroid. So that has its own appeal. They both have appeals. And then there's that scary little dangerous thing we know about the dinosaurs getting clobbered 65 million years ago. And there's been other great extinctions, 251 million years ago, the Permian dying, and others too. So there's always that life-changing biosphere altering risk to them. So you put it all together, yeah, and of course we want to keep watching. And the fact that sometimes they come in and you didn't even see them coming, like that one a few years ago that clobbered Chelyabinsk in Siberia. Nobody even saw that coming until it happened, and no one saw this coming until earlier this month. So, wow,
right.
look at that. Spooky. What a
Great
great
story.
name. I'm so glad that Slooh named it Spooky, because even looking at it,
Very fitting, I think. Very fitting indeed. Bob, it's a great pleasure having you on the show. Bob Berman, Slooh astronomer, thank you very much. And we'll see you again very shortly on another show.
Okay, thank you, Paul.
Oh, Bob's always great to listen to. We always love listening to Bob. Now, that public reaction to space is incredibly important to us here at Slooh, which is why we started our new Golden Record. And on the Golden Record, you'll find fascinating facts, stellar images, literally and figuratively, I think, and enough space-themed music to DJ your next meteor shower or eclipse event. And of course, art, fine art, and more, well, you know, kind of fun stuff like this one made in honor of Spooky Week. So the Golden Record is now officially open. You can log on at goldenrecord.slooh.com and start filling it with your favorite space related images, music, articles, literature. Plus, you can interact with others by liking and sharing posts, or keep the conversation going by adding your own comments. So head over there after this show. It's something we're quite proud of, but we want your input to it. So please come along and support that effort. We're going to take a short commercial break for a moment, but when we return, we'll be speaking with Lindley Johnson. He's the Near Earth Object Program Executive over at NASA. And we're going to be talking about how the agency discover and track asteroids and their plans for that in the future. So we'll see you very, very soon. We've all seen the asteroid, comet. We've discussed the science and the potential risks, and we know all about how we track asteroids. But what we don't know yet is how those who find the largest number of near Earth objects feel about the program. We're joined now by Near Earth Object Program Executive Lindley Johnson at NASA by phone to discuss NASA's program as it is and their plans for the future. Welcome to the show, Lindley.
Hello. I'm getting a bad echo, but I think we can go ahead.
Okay, sorry about that. That's a difficulty calling in the phone. Now, our viewers at the moment are seeing some data from the Near Earth Object Program, which shows how many asteroids of various sizes you've been able to discover. Now, this is the your asteroid census, I believe, from 2011. But these numbers haven't changed much in the intervening years. Now, you've managed to track, which is an amazing achievement, the most massive 90%, I think, of all of the most massive asteroids a kilometer and larger. But when it comes to those over 300 meters, like 2015 TB145, which is what we're looking at today, the discovery numbers drop considerably. Why is it proving so difficult to find these mid-size objects?
Well, I'm not quite sure what you're saying because the numbers of asteroids 100 meters or more in size, the numbers that we found in the last few years has increased considerably.
Oh, well, this was Amy Mainzer, who I believe is a senior research scientist at JPL. And when we were asking about the figures from her, she gave us the 2011 census and said that the numbers hadn't really changed much in the intervening years.
Well, I'm not sure exactly what numbers you're working with, but we are now over 13,000 objects discovered, of which about 6,700, 6,800 of those are larger than 140 meters in size. And we're finding some 1,500 objects a year now, of which about a third of those are the 100 meter and larger in size, 500 or so a year. But with the technology we have from ground telescopes, it takes time. The objects have to come close enough to the Earth that they have a bright enough signature that they can be detected.
Yes, so, you know, basically the smaller they are, the more difficult it is to find. I know that's stating the obvious for some of us, but maybe not for some of our viewers. Now, we discussed earlier with Keith Cowing of NASAWatch.com, the budget for the Near Earth Object Program has increased dramatically in just the last few years. What's been the main driver, Lindley, behind that increase in funding?
Well, it is the government, U.S. government, realizing that this is a hazard, serious hazard that we need to be looking at, tracking, and so we're able to determine whether there is anything out there that is a impact hazard in the next few years, so that we find it enough years in advance that we're able to do something about it before it does have a devastating impact.
Which is absolutely key, and this is some of the theme of today's show. It's about finding these objects, you know, with sufficient time so we can mitigate the impact. So we found you found very successfully over 90% of the large potentially cataclysmic asteroids. Is that correct?
Yes, we believe at this time we're over 90%, probably around 93 to 94% of the 1 kilometer and larger. We have 875 in the catalog now.
And we know, don't we, with quite a high degree of certainty that none of those are going to impact Earth either now or in the future.
Yeah, that's correct. None are in trajectories that bring them close to Earth for the next century or so. Close enough for an impact. Now there are some that do come within a few million miles of Earth in that time frame. I think we have one in perhaps December that I think it's, I can't remember the date in December, but it comes within about 2.5 million miles. And it's an object that's about 1 kilometer in size.
So we know that the actual risk of one of these ones is incredibly low, almost to the point of it just not being a factor at all. And we've already spoken about how important it is that we discover these objects, of both the larger ones and this mid-range as well, with as much warning as possible. So what I can't get my head around at the moment is why NASA is spending this $1 billion on the spaceship for the redirect mission, and this mission is to nudge one of those larger objects out of the way. But why would we be spending that amount of money if we don't really believe that that's at risk? But we do think we could do something with sufficient warning, so we should be finding these things, shouldn't we?
I don't think you understand the purpose of the asteroid redirect mission. That is a technology capabilities demonstration for the capabilities that we will need to get human spacecraft, human missions to Mars. Its primary purpose is demonstration of solar electric propulsion and robotic automated techniques for moving large masses and interplanetary trajectories.
Oh, that is a misunderstanding, because certainly the way we, and I think the general public maybe interpret the redirect mission is very much focused on moving one of these large objects out of the way if it's on a trajectory for Earth, but
Well,
it's not for that.
That's what we are doing to demonstrate the capability of moving large masses. Instead of us with this initial capability having to launch a large mass up to move it around, we just are taking advantage of what's there already, i.e.
Right.
An asteroid that's in a near Earth orbit, plus the advantage of doing that. We get some good science out of it. We're going to go to an asteroid that the scientists are interested in, carbonaceous type. And we get the chance to demonstrate a gravity tractor asteroid deflection technique that might be useful for a planetary defense capability should we find ourselves in that situation.
So, just based on that, the OSIRIS-REx mission, which is to go out to the asteroid Bennu and bring back a piece of that, why aren't we why aren't we grabbing an asteroid when it's closer to Earth? Is it because of the lead times that are required to plan these things?
Actually, we are doing this when they are in close proximity to Earth. They have to be in a trajectory that we can launch a robotic spacecraft and get to them within a few months, and then return what is collected back to Earth. In the case of the asteroid redirect mission, returning a large boulder into a lunar orbit, so that it then is available for visiting by a human crew in the mid-2020s.
Well, we've certainly got you've got exciting times there, and we're certainly going to be watching progress on all of these projects very closely here at Slooh. Lindley, thank you so much for spending the time with us today to explain a little bit more about what you're doing now and in the future. It gives us a little bit of comfort knowing that you guys are working so hard there in the background, largely unseen though. So we like to try and raise your profile as well. So thank you very much for joining us on the show today.
Well, I appreciate that. We kind of like to operate below the radar and use our radar for looking at these objects as opposed to being focused on us.
Oh, well, very good. Thank you very much indeed. Lindley Johnson, Near Earth Object Program Executive at NASA. We are going to take a short break before I come back and tell you some more exciting things about Spooky, the Halloween asteroid. What a fabulous way to spend Halloween watching Spooky the Halloween asteroid as it made its closest approach to Earth. We are looking here at the images taken by Slooh members. What we can see here in this image, the background stars, that huge flare up in the top left-hand corner, that's just a flare from the moon affecting the telescope. But you can see Spooky whizzing across the screen there at this incredibly high speed. This is faster than any asteroid that we've seen for a very long time, which actually, as you heard earlier, is one of the reasons why we think this might be the dead core of a comet. We're getting some great comments. We've been having some great comments at Slooh Spooky on Twitter. We are always here to answer your questions as well. What could happen if an object of this size hit Earth? Would it break up at all? Well, we've already heard on that one from Dr. Mark Bosler at the beginning of the show. Don't forget, Slooh members can rewatch any of our shows as well. So if you haven't seen that segment of it, please go back, have a look. It would be large enough to make it through the atmosphere. An object like this would not burn up in the atmosphere like the Chelyabinsk meteor that we saw a couple of years ago in Russia. This would make it through to the ground, and if it impacted here at our studios in Connecticut, we would be looking for some new staff, basically. It would leave a crater roughly 6 miles across. This is what Dr. Mark Boslow told us. Now, the fallout from an object like this as well is not the global killer that you see in Armageddon and Deep Impact. And we have to stress this object was never going to hit Earth, and we've been very clear in saying that. But what we also want to get over to everybody is the real story behind this. This is a rock large enough to make it through Earth's atmosphere, to impact Earth, which was only discovered 3 weeks ago. And what we've been doing is we've been talking to experts to understand the risk of an object like that hitting Earth, but also to find out from people like NASA and their Near-Earth Object Program what they're doing at the moment and what they're planning to do in the future to make sure that if one of these objects did come through, we'd have sufficient warning to move populations away from the impact zone. So we hope you've been enjoying that. Can the gravity of Earth pull this asteroid in? Well, yes, it does affect the asteroid, but not in any great way. And we are able to include that in our calculations of its orbit through the solar system. The biggest pull in the solar system on asteroids, and actually it both hoovers up asteroids for us, so it's kind of like the solar system vacuum cleaner, but it can also throw these rocks in our direction, is the gas giant Jupiter. And Jupiter's actually responsible for taking quite a lot of asteroids away. And in fact, Slooh members a few years ago witnessed the very explosion as one of these objects hit Jupiter's outer atmosphere and left a rather large pockmark in a live Jupiter show that we were doing. Now, that has been a fabulous way of enjoying Halloween. Look at these radar images that came in from the Arecibo radio telescope. We've also been looking at live images from our partners in China, seeing Spooky whiz across the sky. We've seen those fabulous images from Slooh members that have been taken. They've been using Slooh's Canary Islands and Chile telescopes, robotic telescopes, by the way, that anybody can use. Here we go. Of Spooky. This is last night. Spooky whizzing across the sky. I absolutely love that image. I mean, it just says everything about what we've been trying to do today. And you can see, yes, it's a long, long way away. But how about those radar images showing us what has now become known as the skull? Spooky the skull. When we named it Spooky on the 20th of October, just days after its discovery, who would have thought that we'd land up seeing this huge skull-shaped dead comet in the wonderful radar images we've been seeing today. And Slooh members are going to continue to track Spooky over the coming days as we watch it head back out into space. Now, if you've enjoyed what we're doing, you can see live astronomy every single night over at Slooh with what we call Nightlight. These are live telescope views of fabulous celestial objects. Here we can see the Chile Observatory live views of a gorgeous globular cluster. Or maybe you want to see the moon up close and personal through one of Chile's telescopes. We include loads of fascinating factoids, and other Slooh members control the telescopes to show us their favorite object. Look at that one. That's one of my favorites as well, the Silver Coin Galaxy. So if you enjoy what we're doing, come along, support us, and you get all of this thrown in, live celestial views every night. Well, it's time for us to wrap up now. As much as I love looking at these fabulous images that you can see every night at Slooh. Listen, we've really enjoyed ourselves today. I hope you have too. We've had fabulous guests today. We've had Slooh astronomer Bob Berman. We've had impact specialist and physicist Dr. Mark Boslow. We've had Keith Cowing of NASAWatch.com, and then very generously Lindley Johnson of the Near Earth Object Program at NASA joined us to tell us what they're doing about finding these objects in time, to give us time to do something about it. So we hope you've enjoyed the show today. Happy Halloween to all. Hop along to Slooh and support us, and there's loads more that you can do over at slooh.com. So we'll see you soon. Goodbye for now. Ask the dinosaurs about that one. Now, it's why asteroids really like Spooky, the Halloween asteroid, continue to make international headlines. But what are the risks that these things really pose? And what are we doing to mitigate that risk? Now, these are the questions that we're going to be posing to an incredible lineup of experts today. We've got Slooh astronomer Bob Berman. We've got Dr. Mark Boslow, Keith Cowing of NASAWatch.com, and NASA's very own Lindley Johnson. Now, if you'd like to ask any of our guests a question, you can do that on Twitter by using the hashtag SloohSpooky. Now, this story all started when this potentially hazardous asteroid was discovered just 21 days ago. From observations yesterday, we know that it's 600 meters wide. That's nearly 2,000 feet across, and it's moving at an incredibly fast rate. Now, we need to understand a little bit more about this strange skull-like object. You're going to see this in a minute, and why scientists are so excited about it. So what is it, first of all? Look at this fantastic image coming in. This was yesterday, the radar images. Now, I hope you enjoy what we've put on for you here. We've organized not only a large asteroid or comet making its closest approach to Earth on Halloween, but we even arranged for it to look suspiciously like a skull. So what is it? What is a potentially hazardous asteroid? Well, what we think is that it's the heart, the core of a dead comet. Now, we need to be very clear from the outset that this asteroid or dead comet is not going to impact Earth anytime in the near future. But that's not the real story here. The real story is that an asteroid this size was only discovered 21 days before making its closest approach to Earth. So what makes Spooky unique? Well, there are suggestions, as I say, that this is the core of a dead comet rather than an asteroid. And what leads us to that suspicion is that it had a very strange orbit, and it actually points to why this wasn't
Field of diamonds in the sky, worlds a whirling right on by. Are you wondering who am I? Field of diamonds in the sky.
Welcome to all our viewers at slooh.com, those watching on social media, and especially to all those watching on NASA TV. Today is the culmination of Spooky Week as we discuss potentially hazardous asteroid 2015 TB145, or Spooky, as it makes its closest approach to Earth in just 30 minutes time. Now, since Earth formed some 4.5 billion years ago, it suffered countless impacts by asteroids and comets. And depending on their size, they could cause massive damage either locally or global scales. But I mean, look at this image that came in yesterday from the radar images. I mean, what do you think of this? What do you make of that?
Oh, this is beautiful. I mean, it's such a high resolution, nice image. You can see it rotating. You can see features on the surface. This is great science.
It is, and we're going to be getting even higher resolution images, radar images of Spooky over the coming days as well. Now, according to data from, I think it was 2010, 95% of Earth's population lives in just kind of 10% of the land. 47% I think, of continental US is unpopulated. So given those kind of numbers, what's the likelihood of an asteroid like this striking a population center?
Well, the probability of something like this hitting the Earth in the next year is about 1 in a million. And so given that only about half the Earth, or half the land mass, which is only a third of the Earth, is populated, the probability of hitting the Earth, hitting a population place where people live is about 1 in 10 million in the next year. So it's extremely unlikely.
Extremely unlikely, but I don't know the actual figures, but it's probably more likely than me winning the lottery.
Yeah, something like that.
Kind of puts it in some odd context there, but anyway. So
Yeah.
if an object this size, and what we were able to get, the size range of Spooky was originally put just through the optical observations that Slooh members and other people were making of it. We could only estimate its size by its apparent brightness, and the estimate was 290 to 650 meters. That's about 1,000 to 2,000 feet, somewhere in that range. But it was those radar images yesterday that enabled us to pin this one down. And I believe we've got a fairly good measurement of 600 meters across, don't we?
I think we do. And the reason that the size estimates from optical astronomy are so uncertain is, like you say, we don't
Discovered as quickly as maybe we would have hoped. And its highly inclined orbit really put it outside of the main zone, as we'll hear later, where most of the searches for these near-Earth asteroids and comets actually occurs. And the other thing that makes us suspicious that it is a comet is that incredibly high velocity that we see as it whizzes by. We've got some live images coming up later that you're going to really enjoy. You'll see just how fast this thing is moving across the sky. So what do we do in order to discover and track these asteroids and comets? Well, Slooh members have been tracking asteroids for a long, long time now. We've got a great track record in monitoring asteroids. And it was back in 2008 with asteroid 2008 TC3, and that was the first asteroid to be discovered before impacting Earth. And Slooh members took this very image. There were a handful of only a few people around the planet who managed to image it only hours before it impacted the skies over the Nubian desert in Sudan. So that one kind of took us all a bit by surprise, and it is what alerted a lot of us at Slooh to get involved with this and maybe try and raise the profile of this. So we were hoping to have Bob Berman join us, but we are going to invite Dr. Mark Boslow, longtime friend of Slooh and expert in in impact studies. Dr. Boslow, thank you very much for joining us. It's always a pleasure to see you here at Slooh.
Sure, happy to be here.
So, when was the last time an asteroid the size of Spooky? When was the last impact to Earth of an object of this size?
Oh boy, I guess I don't know the answer to that question. There is a database on the web in which you can look up various craters and crater sizes, and it has a list of their ages. This would generate a 6-mile wide crater if it were to hit the Earth, something of this size and speed.
Well,
I don't know how bright it is. We don't know the albedo. We don't know how much light it reflects until it gets close enough to resolve. And in this case, it did. And in fact, with the radar astronomy, the size could be determined very accurately. And it was at the high end of the estimate because it turns out to be very dark. It's not a good reflecting surface.
so I mean, this just it really illustrates just how very little we normally know about these objects when we can only see them through optical telescopes. And this is one reason actually why this particular close pass and all of these close passes are so valuable to scientists when they come within the range of the radar, the radar telescopes, the radio telescopes. And going back to this image, I mean, we saw this yesterday, and you know, it was just remarkable to see, and how cool to have that. I mean, you know, human beings are good at looking for patterns, but how cool to have this kind of skull looking back at us on Halloween. So we know this is about 600 meters in diameter, which is nearly 2,000 feet. What kind of damage would an object like that? And we have to stress, this is not going to impact Earth today. It's whizzing by, it's a stone's throw in cosmic terms, but it's not going to impact Earth. If an object, though, Mark, of this size were to impact Earth, what would it do?
Well, it would create a crater. It would come screaming through the atmosphere. It would hit the surface. It would lose some energy to the atmosphere as it comes in and create a giant fireball. When it hit the surface, it would explode. It would explode with an energy of about 30,000 megatons, a megaton being the size of a large nuclear explosion. And it would create a crater about 6 miles in diameter. It would shake the ground. It would generate an earthquake of a magnitude of about 7.6. And it would blow trees down and destroy buildings over a radius of about 100 miles. So it would create a lot of havoc.